Okay. So conjecture. Have we heard that word before?
Never.
Making a conjecture?
Never.
I'm
Never.
guessing it's never an educated guess.
Well, yeah, I mean, it's right there. It's an educated guess. So in mathematics, it's something very specific. Oh, because you came in a little late.
They let us out of Spanish.
Oh, were you in that same class? Okay, in geometry, a conjecture is really important.
Oh, I have this.
Oh, you have that? You just... So, in general, to make a conjecture about something is to, okay, let's focus. Okay. You can make an educated guess about anything, right? Okay. Inductive reasoning is when we use a number of specific examples to make a prediction, okay? You actually use inductive reasoning a lot in science. You might not call it that, right? Where you do experiments and you...
CER.
Whoa.
CER.
Whoa!
All right.
English, it's called CAF.
All right.
Claim analysis, something else.
Okay, Evan, are you raising your hand?
I am not.
I mean, you're raising your hand, but are you intending... I mean, it's raised.
Do you want to
Like-
answer the question?
It's lifted in this case.
Okay, continuing. All right, example 1. Eric was driving his friends to school when his car suddenly stopped 2 blocks away from school. Okay, raise your hand if you have a conjecture. Oren, raise your hand, Oren. Flat tire. Alex.
The carburetor was flooded and therefore the engine kind of seized.
Okay. I'll flex that car knowledge on us, bro.
Out of gas.
Okay, okay, guys, I asked you to raise your hand because it gets a little flooded. Rosie,
No more gas left.
no more gas. Okay, the bottom line is
The world blew up.
the world.
Wow.
Oh, that's morbid. Okay,
Very true.
I mean, it could be.
I mean it could. So,
I feel like he had bigger
His
problems.
battery died.
all right, these are educated guesses, right? Do we know if they're true or false? We don't know. We're just making a conjecture.
What is it? Carburetor? Is what injects. Yeah, what injects.
I don't
fuel to the engine.
know. What's that word?
Carburetor. Don't worry if you spell it wrong. It's not important. This is not an important thing, okay? This was just an example of how to make our educated guesses. Now, in geometry and in math, we want to be more precise, okay? So these are called triangular numbers, okay?
No more gas.
We have 1 dot here, okay? Then we have 3 dots. And then if we build this out, we have these triangular numbers. So this is a 4 by 4 by 4, and then 5 by 5 by 5. So can you make a conjecture without drawing it out what you think the next number, or
I said 21.
what do you think?
18.
18? What were you going to say?
21.
You're going to say 21? So how are we getting that 21? Oren, since you...
Because if you go 1 to 3, that's plus 2.
Okay.
3 to 6 is plus 3. 6 to 10 is plus 4. 10 to 5, 15 is plus
Okay.
5. Oh, I see plus
Totally
6.
different.
Okay, how did you see it, Alec?
What? Yeah.
How did you see...
If you add 1 dot on the side of every line, and then you just add 1 for the top, it's 6.
So adding 6. So he was looking at the figure, you were looking at the pattern in numbers. It doesn't matter how we arrived to that conclusion. The next number is going to be 21. Okay. Now in math, as I mentioned, up here, we don't know. We can't make a really good conjecture as to why the car stopped. But when we make a conjecture in math, we want it to be a correct conjecture based on the pattern. All right. So let's look at these number sequences. Again, we just want to make, what's the next one in this sequence?
Negative 19.
-19?
Yeah.
What do you guys think? So let's see, did you do -4? -5, -6, -7, -8, -9?
Minus 18. Negative 18.
But this one's -8. 8, so minus 9.
Oh.
Okay. How about the 2, 4, 12, 48, 241,440?
This number's so big though.
That's okay.
Whatever that is times 6.
Okay, yeah, so this is going to be times 2, times 3, times 4, times 5, times 6. So we want to multiply it times 7. Anybody have their calculator handy?
7,
I need a
8,000.
calculator.
It's a very
10,000. 10,080.
Oh, 10,080?
1008.
80.
1008. Yes.
Okay. Good. All right. Next, we have counterexamples. Okay, so how do we know if a conjecture is true or false? If it has what's called a counterexample, then it's a false conjecture. Okay? So one false example is to show how a conjecture is not true. Okay? If a conjecture has to be true, it has to be true in all cases. So we just did those number examples on the bottom of the previous page, right? There was only one answer there, right? There was only one conjecture. All the other ones would have been false. So now we're going to see kind of in geometric terms what that looks like. So again, here's what we're going to make sure. You have to have it written out in detailed words. You can also make a picture, but we want to make sure it's labeled. Again, it's about being specific. Yeah, Liam.
If it's true, you just write true.
That's all you have to do. So determine whether each conjecture is true or false. And then we want to write a counterexample for anything that's false. Okay, angle 1 and angle 2 are supplementary angles. Okay, that's what we call a given statement. So you're given this is true. Okay, and our conjecture is angle 1 and angle 2 are both right angles. False. Okay, so that's false, Rosie.
Wait, so I can just draw a picture of it?
Yeah.
Wait.
Sure. So I want to make sure this must be true.
So just make them a linear pair.
Yeah.
Okay, so we can make them a linear pair.
Make one up.
Okay, but I need to be specific. So we're going to put in, first of all, these angles had names. They were angle 1 and angle 2. So I also need to include numbers. So give me 2 numbers that are not 90, Alec.
Can't you make them
91 and 89.
Okay, so you can make this 89 degrees and this 91.
Can't you make them 90 and 90?
Okay, but the conjecture was that angle 1 and angle 2 are both right angles.
Yes.
So does that always have to be true? Okay,
So
remember,
if it can be sometimes.
Oh, good.
okay, remember all those questions?
Always has to be.
Okay, always, sometimes, and never. If it's sometimes or never true, that means we have a counterexample. If it's always true, then we're just going to put true for these. So remember on the test how I had some always, sometimes, or never? Right? Anytime sometimes comes up, we have a counterexample.
What about like for this one, like the first example?
Yeah.
What about like the flat tire?
So we would need more information. All right, let's look at another example. Oh, Liam. Yeah.
Ow.
Another example.
That's false.
I was giving him
All right.
Another example.
You want an example? A counterexample?
No, he gave me another.
Oh, okay. It could help the whole class if you have another example too. 110 and 70, yeah? Okay. All right, given points A, B, and C are collinear, my conjecture is B is between A and C. False. Now, what do I want to draw? I want to make a line.
Line with C and then C and then A.
So-
you have to draw it to me right.
C A B.
Okay, me personally, I like drawing a picture. Okay, it's fast. It's easy to just draw it where it's not true. Now sometimes we need to write an explanation. So Evan, you asked, can you write it out? Sure, you can write out. What would I write for this? I could say A can be between C and B. For me, I like to just draw the picture, but just make sure you label the points. Okay, so far, we're okay? All right, last one, and then actually we're moving on to the next section because this was a fast one. N is a negative number. Is n squared a non-negative number? That's my conjecture.
True.
It's true in every case.
Yes.
A negative times a negative is one. Oh, wait.
Is it? Yeah, that works too.
It's
Well,
not
n
negative,
can't be
that
zero.
works. No, n can be.
Right, so what was the problem with n equals 0? Good catch.
Non-negative.
Oh, it was non.
Yeah.
0 isn't possible.
Good. Yeah, so if it says it's a negative, anytime I square a negative, I get positive.
Well, if n is 0,
Wait, but
technically
do you
it's
have to
still
draw
not
that
negative,
picture?
so.
No, this is not a counterexample, so I'm gonna just, you don't have to write, if it's true, that's it, just leave it at that.
Well, if n is 0, then technically.
Then it's not, yeah,
It isn't negative.
right.
Not positive either.
Okay.
Some coding of it.
All right, this is gonna be like an English class, a little bit, not really. It does pertain to theorems. Okay, conditional statements. A conditional statement has a condition. So it basically says if this, then that occurs, right? So we call it if then form. So if you buy a car, then you get $1,500 cash back. Okay. So this is in symbols. We use we read it as P implies Q. The arrow actually means implies. So we use lots of like abbreviations in geometry. We've already learned angle and segment and line and all of that. There's lots more. So here's some examples. A 5-sided polygon is a pentagon. We can rewrite this. What's the first part of the conditional statement? Yeah, so what we want to do is we want to rewrite it. We have a 5-sided polygon. So if a polygon has 5 sides, what's our conclusion? Has a pentagon. All apes love bananas. Okay, again, we're just going to write it in if-then form. We're not going to necessarily debate whether it's true or false. If an animal is an ape, then it loves bananas. Okay. Now there's 2 parts to this. One is the hypothesis. This is the portion following if. Conclusion is the portion following then. You're doing hypothesis.
We just did like,
If that's
we were doing, yeah, we were just like identifying what each.
Got it. Okay, so look at that first example. If points A, B, and C lie on line M, then they are collinear. What is the hypothesis?
A, B, and C are coding.
Okay, so that's what we're going to write. We're not going to include the word if, and we're not going to include the word then. So basically, the hypothesis comes after if and up until we get to the comma. Now the conclusion, what comes after then? They are collinear. All right. Not too bad. That first one was already in the correct form. Now the next one is not in if-then form. It says the Tigers will play in the tournament if they win their next game. Okay, so you see how the if is in the middle of the sentence? That tells me that my hypothesis and conclusion are mixed up, right? You got to win the game in order to be in the tournament, right? That's the way it works. You don't play the tournament and then win your next game. So now what's they referring to? Okay, so the Tigers. So I'm going to include the Tigers in my hypothesis because I want to know what am I talking about. So the Tigers win their next game. The Tigers are going to win their next game. That's the So in the hypothesis, I want to be specific. Like, what am I talking about? I'm talking about the tigers.
It's not writing.
Oh, I wonder if it's the internet. It was slow earlier.
Oh, there we go.
Did it come up?
Yeah.
Okay, I can plug into HDMI if it's a problem. Okay, good. Okay, now my conclusion, I can be general, so you can now say, they will win, yeah, they will play in the tournament. Good. Any questions on that? So they will play in the tournament. Okay, questions there? Is it still delaying?
Yeah.
Oh, goodness. Okay. Next, okay. So the next one, we're now going to write these conditional statements in if-then form. Rectangles have 4 right angles. Okay. So what are we talking about?
If
Rectangles. What's a rectangle in a general form? Okay, you could say if a quadrilateral. If you say if a shape.
Why don't you just say if it's a rectangle, then it is 4 angles?
You can even just say if it is a rectangle, then it has 4 right
Not
angles.
all quadrilaterals is 4 angles.
Right. You could also say if a polygon is a.
All quadrilaterals have 4 sides, but not.
So you could say quadrilateral.
Returning email.
Okay. You could say if a shape. You could say polygon. Okay. Then, what are we going to say about it? It has 4 right angles.
What? Then it has 4 right angles?
Right angles.
Oh, if a shape is a, I thought it was if a shape has 4 right angles, then it is a rectangle.
Okay, but look, okay, the only time we have to rearrange the sentence is if the word if is in the middle of the sentence.
Oh, but I rearranged it.
Otherwise, we read it in the direction that it is read.
Okay, but they don't.
Well, just maybe do a little arrow. Because, sure, is it true if we mixed it around? That's also true, but that's what we're gonna do next, the converse. Converse is when you switch things around. So it's really important that conditional statements are read in the same direction. Okay, math teachers love to solve problems. So if what?
If you love to solve problems.
No, what's the first part? Okay, if you are a math teacher, oops,
Then you must solve.
there you go. So if you,
Just go back.
okay. Okay, so the converse, you exchange the hypothesis and the conclusion. So we're just basically replacing what comes at the end and switching it with what comes at the beginning. And in symbols, Q implies P. So here's an example. If 2 angles have the same measure, then they are congruent.
Wait, what does that mean? Q is.
It's just an abbreviation.
Oh.
Q implies P.
If the
If 2 angles have the same measure, then they are congruent. If 2 angles are congruent, then they have the same measure. See how we're just swapping. It's like the hardest thing you'll do all year. Okay. This should be the easiest thing that we do all year. That's the plan. Okay. Conditional.
everything after this one lesson is.
It's not all difficult. Some things are good. Some things will get more difficult, some things will be
geometry we did in
easier.
third grade where it was like
If a person is
one
16 years
find
old,
the
they
area
have
of
a
the
driver's
triangle, one
license. But that's not necessarily true.
Okay, so
It doesn't have to be.
if a person is at least 16 years old,
What if they never want?
okay, hold on. Then
16-year-olds like voted
they have a driver's license. Okay, now, as I've already heard a few of you say, the first part, if a person has a driver's license already, then they have to be at least 16 years old. That's a true statement. However, when we flip that around and we write the converse, if a person is at least 16 years old, then they have a driver's license. That is not true. So this is false. Now, a counterexample. Okay, I'm sure somebody has a family member or a friend. Alec has an example.
Yes.
Who's your example?
Girl in my Spanish class.
Okay. Oh.
I don't know her name.
Okay.
Sarah.
Is it Sarah?
A girl in Alec's
Not every 16-year-old has one.
Spanish class.
What happens if
And do you know how old she is?
At least
16?
16.
Is 16
Definitely.
and doesn't have?
and doesn't have a license.
Not having a license. I know.
Is she talking
My
about
cousin.
Can I say if my aunt is has
Yes, you can say my Aunt May.
I'm confused on how they.
Why do you
I'm confused on how they.
Why she use
That's
that?
evil!
Okay, okay. Questions? Running out of questions?
Confused on how the converse is false.
Because just because you're 16 years old, does that mean you have a license? Like a lot of people wait to get their licenses later.
Oh, I spelled
So-
license wrong.
Not an important detail. Okay, adjacent angles have a common side.
They
Okay,
have a common side, they are.
okay, so
Nice.
okay, now if what? What are we referring to? General. We're referring to angles. So if, and adjacent angles come in pairs. So I'm gonna just throw in the word if two angles have a common side, then they are adjacent, right?
No, I get what you're saying.
Okay. Okay. Write that and think about, don't call out yet, but think about if that would be always true sometimes.
Take it back. I don't want to hear all.
You don't want to be wrong, Lily?
No, I don't want to do
You don't want to do it either, Eden?
Seems to be a common
False.
theme.
How is it false? Wait,
Ariel, what if they're vertical angles?
but they still have a.
Now they have a common vertex on the side.
Well, then they
Wow.
yeah,
Okay.
but-
Can you draw two angles that have a common side that they are not adjacent?
Yes.
What Alex said. Wait.
Okay,
No.
but a linear pair are adjacent.
No, because
Okay, here.
Like, what is it?
a vertical angle.
I'm gonna draw it down.
They're not.
Here, I'm gonna draw it down here so you have
Wait,
more
can
space.
Can you go back to the thing I was writing?
The layer pair has-
Yes.
Okay.
Yes. Those are adjacent.
I'll be wrong.
Angle ACE and angle ACD.
One, two, right?
Yes.
Oh my god, yeah, just did.
Okay. My counterexample is a picture this time. I just drew it down here because there's more space. Do ACE and ACD share a side? Yeah, this one.
Oh.
But are they adjacent to each other?
No.
No, because remember the word adjacent means they can't have any common interior points.
Which is
But,
Oh wait, we can just draw a picture.
vertex.
oh wow, we got lots of time.
What does it mean interior points?
Well, what are the interior points for ACE? Here.
I love mine.
What are the interior points for ACD? You see how they both overlap? Those interior points?
Wait, so what is an example of one
No,
that's
thank you.
like agreeing with
agreeing with the statement, I would have said angle ACE and angle ECD. But
Oh, gotcha.
that one is
Should I use
adjacent.
a counter example then?
Okay, questions?
Should I use a counter example? Draw that.
Yeah, that's your counterexample. All right.
Wait, can you not do? I'm still writing.
That's fine. I just froze the screen. We have some time to get a start on homework. Oh, I also want to talk about homework for a minute. Many of you are not, haven't been taking off points, but I want to make sure that your homework, like when there's just one answer, like to put a circle or a box around it, because I'm like spending all the time like looking for your answers.
What if it's like
Also,
answers right next to the problem?
I mean, listen, sometimes it's like just one answer. You don't need to do it then. But it's like if you're solving for X and then you're finding an angle measure and I'm like looking all around, where is X, where is the angle measure? It just takes a long time. So also on homework assignments,
We have to just.
It was yesterday, man. It was yesterday. You did.